All right, this is the Unit 1 review in AP Stat, just some review problems of kind of everything for us to go over right before the exam. So feel free to pause the video, write the problems down, plug the numbers in to see if you can get the answers as well on your own and see if you get stuck. Anyway, it says here for bananas that here are the prices of bananas reported from 15 markets surveyed, right? So display these data with an appropriate graph. So we all know which graph, right? I could try a histogram, I could try a dot plot, I could try a variety of different graphs, right? Then it says report appropriate summary statistics, and then write a few sentences about it. So you take that data, right? A histogram of the prices from those 15 markets would look roughly like this. If you plug them all in, and after you plug them in, you make sure you turn your stat plot on and you go to histogram and graph it. This is what it would roughly look like. The number of markets, right? Because let's face it here, and this is price per pound. So this is the price per pound as we're looking at this, and there are 15 total markets, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then there's 15. So there's 15 total markets in each range, basically, and it says display these graphs, and I don't know if you could say that any are reportedly skewed or not, but it says a histogram of the prices from the 15 markets as reported appears at the right. Got it? All right, and it says report the appropriate summary. It says the distribution of bananas is skewed to the left. I mean, it does look kind of like it could be skewed to the left, not drastically, right? But it is, I guess, skewed to the left. And it says, so the median and inner quartile range are appropriate here. And again, you're going to want to use mean, and you're going to want to use standard deviation when it appears symmetric and normal and bell-shaped. And that certainly didn't appear that way. So the better data for us to use is going to be the median anyway, because it didn't look like that. And then we're going to probably use the inner quartile range for the spread. Well, to find the median, which is the middle of all of that, you could just arrange them in order and look at it. And then find your quartile ranges from there. But the middle of 15 would be roughly 7, 8, right? So around 7, 8. So 1, 2, 3, 4, 5, 6, 7. So somewhere in between here and here. So somewhere in between 48 and 49. So that's where they're getting the, 48 and 50, which is where the 49 is coming from. And then if that's the middle, around 49, if that's what you choose, then I'm basically cutting the first half in half. So that's about 7 that I'm cutting in half. So after 1, 2, 3, so it's somewhere around in here, which is why they're going with around 46-ish maybe. And then if it's 49 that I'm using 1, 2, 3, so somewhere in between like 50-ish. So to find that range between the two after you cut them, and it might be easier to look at them in terms of numbers at that point, just to see what it looks like. But the point is it's about 7 cents with the spread. And then write a few sentences. It says the distribution of the prices of bananas are reported. It is, for the most part, unimodal, right? There isn't a big, right, a mode real anywhere, right? So we got one little thing that popped up there with the graph, and it's skewed to the left. The center of the distribution is approximately around 50. 49, 50 is the center, with the lowest around 42, which you can get from even just looking at the data, the highest around 53. All right, in a study of dialysis, researchers found that of the 3 patients who are currently on dialysis, 67% had developed blindness and 33 had their toes amputated. So what kind of display might be appropriate for this data, right? So research found that of the 3 patients who are currently doing it. So how do I truly want to show this? Because there are only 3 patients on dialysis. So with few patients, no display would really be needed if you think about it, right? What am I going to have, a histogram of 2 and 1? Right? Am I going to have a stem and leaf plot with 2 there and 1 there? Like, what am I going to have? So we know that 1 patient has had his or her toes amputated, and that 2 patients have had blindness issues. So what we don't know is whether or not the patient that has had his or her toes is blind. I don't know. Right? Is that person also blind? Is there one of those 3 people who has had nothing happen to them? Because that could be a possibility. So even if we wanted to, we do not have enough information that we could possibly display it, if that makes sense. You're assuming that they don't attract one another, right? They are dependent on each other, or maybe they're independent. We don't know that yet. That's what we're going to get to in the next unit. Take a look here. We got a bakery is trying to predict how many loaves to bake. And in the last 100 days, they have sold between 95 and 140-ish loaves of bread. And here's a histogram of the number of loaves they sold for that last 100 days. Definitely skewed to the right. Okay, so they're more down here. So describe the distribution, and that's when we want to use our idea that we talked about called SOX. We want to talk about the center, right? Or sorry, starting with an S, the spread maybe. Is there outliers in the data? Is there a center of the data? What's the spread? So we want to take a look at all this stuff. So take a look at the distribution. And this is given in the problem, so we kind of know what the box plot and everything is looking like, so I don't have to try to hunt through and find it for the data. But the distribution of the number of loaves sold each day in the last 100 days, it's definitely unimodal, right? One little lump there. It's definitely skewed to the right. The mode, right, is definitely here. And it's definitely somewhere in between 95 and, what are we going up by, 5, 10, 15, 20. So is it 100, 105, 110? So not even that. So it'd be varying distances between there. So 25, so maybe 6.5 for each one. Point is, it's definitely in there in this first chunk, which is around 100, and it's unimodal, with the majority of days recording fewer than 120, right? Without a doubt. So the number of loaves sold ranges, though, from 95 to 140. So you try to explain whatever you can as much as possible. We already know that because it's skewed right, we would definitely be using the interquartile range and the median with this data as well. So we get our outliers, our highs, our lows. We get our spreads, right? We know what's happening with it. So we kind of figure out what's going on with the data. Then it says for part B, the mean number of loaves sold will be higher, definitely, because we're pulling it down, right? Does that make sense? That's pulling it down. So since the distribution of sales is skewed to the right, the mean is sensitive to the skewness, while the median is resistant. And then it says create a box plot with quartiles at 97 and 105.5, median 100, so we can easily find the quartile range by subtracting them. And there are several high outliers here, because remember, in order to find an outlier, what you would be able to do is you find the quartiles and you take 1.5 times the interquartile range, and if I go 97 minus that, it takes me down to 84.25. All right, one possible box plot is at the right. There's really no outliers down this way, but the other way, 105.5 plus that, as you can see, we are going to get some outliers with our data if we take the time to do it, just because we can see that that's going to be way out and above it. Like, take a look, see. So if I take the 105.5 plus 1.5 times the interquartile range, which is 8.5, basically I'm looking at anything above 118.25 is going to be that way. Anything above that. And if you look at this, where is it? There we go. If you look at this, anything above 118, well, geez, all of this is going to be up there, right? And there's at least one in each of those. So the reason why that's a big deal is these are all turning into outliers, is what's happening when it's all said and done. Now, this, we don't know where it's at, or this, because it's a range of values between there, so I'm not sure, but it's looking like we have outliers that are hanging around out there. The distribution of daily bread sales is not symmetric, obviously, but it's skewed to the right. The normal model would not be appropriate here, so we're also not going to be able to draw any conclusions with it. Taking a look here, as part of the course work, a class at an upstate New York college collects data on streams each year. Students record a number of biological, chemical, and physical variables, including the stream name, the substrate of the stream, like what's in it, like what kind, the pH, the temperature, the BCI. So they have a whole bunch of stuff. And here's what they get. So it says, name each variable, indicating whether it is categorical or quantitative, and give the units if possible, right? So that's what we're supposed to do. Look at all this stuff and determine what they are, all the different values, and then these streams have been classified according to their substrate, the composition of soil and rock over which they flow, as summarized in the table. What kind of graph might be used to display this? So, point is, we're looking at all the stuff that's in here. They record the number of biological, chemical, and physical variables, including the stream names, the substrate of them, the pH, the temperature, the BCI. So categories, all right, the substrates are definitely categorical, right? Right here they are. All right, quantitative data, a pH is a number that you can add, temperature is a number, you can add, BCI is also a number that we can add. So those are all different measures when you're looking at this. So we took each one and we labeled it. And then it says substrate is a categorical variable. So with categorical variables, we're talking about categories. Pie charts or bar charts are more useful when you're talking about categories of items. All right. So when we're doing these, you'd probably want to set up some kind of pie chart or bar chart whenever you're looking at categorical data. Without diving into this, we'll get back to this when we come back. I don't want to start in the middle of a problem. So we will continue with the review of Unit 1 when we get back.